So students, in this part I will discuss about communication software, communication devices, network communication standard, communication channel, transmission media. In transmission media I will discuss about twisted pair cable, coaxial cable, fiber optic cable and wireless link. First I will discuss about communication software. A communication software that helps in establishing communication over network is called communication software. It helps in receiving and sending the data. Communication software consists of programs that help users establish a connection to another computer or network, manage the transmission of data, instructions and information, provide an interface for users to communicate with one another. Communication devices. A communication device is any type of hardware capable of transmitting data, instructions and information between a sending device and a receiving device. Computers process data as digital signals. Data, instructions and information travel along a communication channel in either analog or digital form, depending upon the communication channel. The types of communication devices are dial-up modems, digital modems, wireless modem, network cards, wireless access points and routers. Next, network communication standard. A network standard defines guidelines that specify the way computer accesses the medium to which they are attached, the type of medium used, the speed used on different types of networks and the types of physical cable and or the wireless technology used. A standard that outlines characteristics of how to establish network devices communication is called a protocol. The more widely used network communication standards for both wired and wireless networks includes Ethernet, Token Ring, TCP/IP, Wi-Fi, Bluetooth, UWB, IRDA, RFID, WiMAX and WAP. Communication channel. It is the transmission media on which data, instructions or information travels in a communication system. Bandwidth. The amount of data, instructions and information that can travel over a communication channel is called its bandwidth. The higher the bandwidth, the more data is transmitted. Transmission media. A communication channel consists of one or more transmission media. Transmission media consists of materials or substances capable of carrying one or more signals. Transmission media are of two types: physical transmission media, wireless transmission media. Physical transmission media. It uses wire, cable and other tangible materials to send communication signals. Wireless transmission media. It sends communication signals through the air or space using radio, microwave and infrared signals. Twisted pair cable. It consists of one or more twisted pair wires bundled together. Each twisted pair wire consists of two separate insulated copper wires that are twisted together. Each twisted pair wire usually is color coded for identification. The wires are twisted together to reduce noise. Noise is an electrical disturbance that can degrade communication standard. Coaxial cable. It is an electrical cable with a conductor at its center. The inner conductor is surrounded by a tubular insulating layer. The insulating layer is surrounded by a conductive layer called the shield, which is finally covered with a thin insulating layer on the outside. Fiber optic cable. The core of a fiber optic cable consists of dozens or hundreds of thin strands of glass or plastic that use light to transmit signals. Each strand, called an optical fiber, is as thin as a human hair. Inside the fiber optic cable, an insulating glass cladding and a protective coating surrounds each optical fiber. Advantage over twisted pair and coaxial cable. Capability of carrying significantly more signals than other wire cables with faster data transmission. Less susceptible to noise and better security for signals during transmission because they are less susceptible to noise. Disadvantage: it costs more, that is, it is more expensive. It is more difficult to install and modify. It is mostly used in telecom companies for different types of connections. Wireless links. Wireless links rely on radio signals for the transmission of data. Wireless communication is becoming popular. A wireless line links devices via wireless distribution methods, typically radio signals, and usually provides a connection through an access point to the wider internet. This gives users the mobility to move around within a local coverage area and still be connected to the network. Students, if you want to get more detail, please have a look at this video.
We're now going to look at wireless transmission media, including twisted pair, coaxial, and optical fiber types of cabling. So, firstly, we're going to look at twisted pair, which may be either shielded or unshielded. Okay, twisted pair cabling consists of two copper wires twisted together. These wires are twisted for the purpose of reducing the amount of interference coming from other types of cabling. Now we can see that the actual twisted cables are insulated in order to protect them and reduce interference, and contain conductors on the inside. Okay, they're commonly used in telephone systems as well as internal wiring in network LANs. Okay, they're suitable for very high bit rates over short distances. Okay, but basically they're cheap and easy to use. The next type of cabling is coaxial cabling, and as you can see here, the copper conductor is very secured. Okay, we've got an outer insulation, a copper mesh, an inner insulation, and then the actual conductor itself. Okay, and so this type of transmission is also used over a short distance, but is a lot more secure and less susceptible to interference. The final type of transmission we'll look at is optic fiber cabling. Okay, here we have covering as well as sheath, but instead of having copper conductors, it has a glass fiber which is very thin. This glass fiber runs the actual transmission many times faster than copper ever could. Okay, so it uses a laser light going down this glass fiber, okay, which is the diameter of a human hair. Okay, it is free for any type of EMI or radio interference and can go over very long distances. This is the type of cabling they're trying to bring in with the national broadband network to increase the internet speeds within Australian network systems. Okay, so let's look at all these types of cables side by side and compare them. So basically, each one is used in order to physically connect network devices. So they're all wired, they're all physical, we can touch this type of transmission media. Okay, both twisted pair and coaxial, okay, have pretty short distances. With twisted pair at about 100 meters in length, it can go over. Coaxial at 500 meters, but optical fiber, we can go to 10 to 12 kilometers running cable. Okay, the speed is about 10 to 100 megabytes per second for a twisted pair. Same for coaxial cabling. Optical fiber, 10 to 100 gigabytes per second. Okay, hundreds of times larger. Okay, twisted pair is the cheapest, but coaxial is also very cheap as well. But optical fiber is quite expensive to set up. Okay, and it's also very delicate, so you've got to be very careful when using the actual type of cabling. Okay, twisted pair is cheap and easy to install as its advantages and is widely available and used. Okay, coaxial is less susceptible to EMI interference and carries several signals at a time. Okay, so it's better than twisted pair. Though optical fiber is secure, it can go over longer distances, has no interference, and has a much higher bandwidth with lower errors because of this less interference. And the disadvantages of each is that basically twisted pair, you can't get it very far and it can pick up interference. Coaxial can be hard to work and can be tapped, okay, meaning people can access the actual transmission, okay, and failure can bring down a whole network. Whereas optical fiber is extremely expensive to install as well as to terminate, and you need terminators to convert the data. So I hope that gives you a bit of an insight into the three types of transmission media used for wireless data transmission. We're now going to take a look at a few methods of wireless transmission media used in communication systems, particularly the styles of microwave, satellite, radio, and infrared. The first one we're going to look at is microwave, and basically a high frequency signal is sent from big towers. Okay, these towers are known as transponders. Okay, and they're placed about 40 to 50 meters apart. Okay, and the signal is sent directly through line of sight from one tower to another. So if we're going to take a look at what this looks like, here are our transponders. Okay, and they're all spaced out, and then they basically send a signal that is about 40 to 50 kilometers apart. Okay, so if we're going to space them out, we need to space them out in that distance and send the actual signal from one transponder to another, and that's how it spreads over a wide geographical region. Okay, this type of microwave communication is used by telephone networks, internet service providers, as well as other companies using remote monitoring and management. The next type we're going to look at is satellite. Now, satellite tries to eliminate the line of sight barriers that can often happen, okay? Geographical sites often have buildings and things that get in the way, so transponders may not be effective in getting the signal around. So what we do is we set up a satellite. So we set up our transponders, okay, and they're still spaced out far apart, but we set a satellite up in space, and that satellite rotates with the rotation of the Earth. So it's always kind of in the same geographical location above the Earth, moving with the Earth's movement. When data is sent up to the satellite, it is known as an uplink. Okay, and then when the satellite returns that same data back to the Earth, it's known as a downlink. So basically, it's the greatest distance we can send a communication signal, okay, using communication technology. Next, we'll look at radio waves, and radio is basically used for our wireless technologies. Okay, we all know of radio towers giving out a radio signal to listen to on the radio, but also it's used for technologies such as Wi-Fi when we set up our home Wi-Fi networks, okay, as well as other technologies as RFID, okay, NFC, which we do our tap and go with, okay, as well as Bluetooth when we pair up our devices. Okay, so if we have a look, here's my router, and that can act as the center of my radio network. It will send out a signal, okay, and it may allow for my PC to connect with my printer, okay. It may also allow for my TV to connect with the internet, okay. So we can build up these wireless networks locally within our house using radio technologies, as well as in shopping centers and at McDonald's, the way they've got their hotspots, so that all these different devices can communicate with each other without any type of cabling necessary. The final one we're going to look at is infrared. Okay, and infrared basically is the simplest form of communication. It's just a line of sight using the infrared laser. Okay, the actual type of light used is a very low frequency. Okay, and it's direct line of sight. Okay, your TV remote with your TV uses infrared. You basically have to aim the signal directly at the receiver for it to hit, and it's usually over a short range. Okay, so we've got to remember that. So in order to illustrate this, okay, here's my TV, here's my remote control. Okay, and if I'm going to make my remote work and communicate with the TV, I've got to aim it directly at the TV. Okay, it will hit the sensory bar in the corner. Okay, and the TV will respond. It will turn on. It will do whatever. But if there's anything in the way, okay, the signal will not communicate with the TV and it's easily blocked. So that's the main downfall of infrared. But it's simple, cheap, and easy to set up. Many things still use infrared technology. So we've obviously got home entertainment, but intrusion detectors, fire detectors, medical diagnostic equipment, where we are close range. Okay, and we've got direct line of sight from the sender and the receiver. So I hope this all gives you a better understanding of the wireless communication mediums that are in existence of microwave technology, satellite, radio, and infrared, and basically where and when they're used, okay, throughout communication systems.
Solution that is based on previous video. Question number 1. Define bandwidth, protocol and communication channel. First, bandwidth, the amount of data that can travel over a communication channel is called the bandwidth. For example, a 2-lane road can allow 2 vehicles to move on it, and 4-lane road allow 4 vehicles move on it. Similarly, 1 MB, 10 MB or 100 MB bandwidth specify that 1 megabyte, 10 megabyte or 100 megabyte data can travel over that channel. Protocol, the set of rules, guidelines or layout defined for communication over the internet is called protocol. These rules make sure that our communication on internet is safe and reaches the destined receiver in its original form without any loss or distortion. Protocol decides how a message will go from one computer to another, how it will be broken into how to add the sender and receiver address, and how to check the integrity of the message that is transmitted. Examples of protocol are TCP, IP, UDP, STTP, STTPS, etc. Channel. It is the path over which the data travels. A channel is required for communication. For example, air serves as the communication channel between us. When we communicate with anybody, without air, there will be no communication. Similarly, for communication between two or more devices, a channel is required. There are two types of channel available: wired channel, wireless channel. Question is, how many types of transmission media are there? There are two types of transmission media. Wired media. It consists of twisted pair cable, coaxial cable and fiber optic cable. Each cable has its own advantages and disadvantages. Wireless media. It uses radio links for transmission of data. Wireless LAN provides access via access points to the devices. The benefit of wireless media is that the user can move around and still stay connected. Write short notes on communication software and communication devices. Communication software, a software that helps in establishing communication over the network. It helps in sending and receiving the data. Communication software consists of programs that help the user to establish connection to another computer, manage the transmission of data and instructions, and provide an interface to communicate with other users. For example, Skype, Gtalk, MSN, Messenger, email, newsgroup, chat rooms, video conferencing. VoIP means Voice over Internet Protocol. Communication devices. It is a type of hardware capable of sending and receiving data and instruction between two or more devices. The types of communication devices are dial-up modems, digital modems, wireless modems, network card, wireless access points and routers. For communication over internet, we need both communication software and communication hardware. We cannot communicate if anyone is missing. Give 2 examples of network protocols. Answer. The protocols used are given below: Ethernet, token ring, TCP/IP, Wi-Fi, Bluetooth, UWB, IRDA, RFID, WiMAX, WAP, UDP, STTP, STTPS, etc. For today is question number 1. Write full forms of the following: TCP/IP, UDP, Wi-Fi, WAP, STTP and STTPS. Question. Give the name of transmission media used in wireless communication. Third question. What do you understand by network topology? Explain its type. Last question is fill in the blank. Topology is commonly used in wireless networks.